So let's say we have an object placed on a rough surface, and when we apply no force, when applied force is zero, the friction will be zero, right? And when we increase this force gradually, the friction also increases. And also we know the friction is equal and opposite to the applied force. And we know there is a maximum value between the contact if we consider a two object. Now, for example, if I take uh, this and this, so to these two contacts, there is a maximum friction value. That maximum friction value is known as limiting static friction. Okay. So we can summarize this entire thing from the graph. So we drew the graph last week. So when the applied force is zero, so here this is the applied force, applied force and friction. When the applied force is zero, we know the friction is zero. And then what happens? When we increase the applied force, the friction also gradually increases. So it has a linear relationship, y equals x, because we know when the object is not moving, the applied force is equal to the friction, right? Applied force equals to friction. So therefore, here it will be y equals x relation. So this angle is 45 degrees. And then we know this friction has a maximum value. So if the applied force goes beyond that maximum value, what happens? The object start to move, it will slides, right? So then that suddenly value decreases and then it has a constant value. So this maximum value is known as the limiting static friction. Limiting static friction, which is denoted by Fs. And this value is kinetic friction Fk. And both of these limiting static friction and kinetic friction coefficient both are proportional to the normal reaction force. So the normal reaction force, let us mark here as capital R. So we can write Fs is proportional to R, therefore Fs equals to nu SR. Similarly, Fk, the kinetic friction, also proportional to R. Fk is equals to nu K times R. Okay, so here nu S is known as the static friction coefficient. Static friction coefficient. And here nu K is known as the kinetic friction coefficient. Okay, and we know by looking at this graph, we can say that Fs is smaller than, Fk is smaller than Fs. So Fs is greater than K. Therefore, here we can write nu K times R is greater than nu S times R. Therefore, nu K is greater than nu S. Okay. Because we know when it's easy. Now, for example, let's say there's a heavy table or heavy almirah on a rough surface. It's you need a large force in order to make it move. But once you start moving, the force required is less than the maximum force required to make it move, right? So therefore, this nu S is smaller than. Sorry, I think here I wrote wrong. Here it should be new SR, here new KR. So new S is greater than new Q. Okay, right. So this is a quick recap of what we discussed in the last class. And regarding the friction, this is the most important things. Okay, so you should know this. And also here, always if the object is at rest, the applied force is, the friction force is always less than or equal to Fs, where Fs is the maximum value that the friction can take between the two surfaces. Okay, right. So with reminding this, so we can move on to the other things. Let us discuss a couple of applications of friction. So one thing is, we know friction is very important force in our day-to-day life. Guys, do you find the video is lagging? Is the video is lagging? And how about the audio? All clear, right? Okay. So friction is very important force. Now, in fact, we can't do anything if there is no friction. Okay. Now, for example, we can't even walk. If you want to walk, the friction should be there. If there is no friction, we are not able to walk. Okay. So, because how we walk usually, if you want to, now for example, uh, according to Newton's first law, if an object is at rest, if this want to move, or if this object want to gain some velocity, it should experience some external force, right? Now, according to Newton's first law, you can recall Newton's first law. Uh, Unless an external force is unbalanced force is applied, the object at rest remains at rest. Object in motion remains in motion. So then, if we decode this Newton's first law, the object which is at rest, if you want to make it move, we should apply a force, right? So therefore, how do we apply a force? So one thing is, one way is if someone is standing, someone can come behind and push by a large force. So that way make someone move, right? But normally we don't do like that, right? Now, let's say if you want to walk, your brother comes behind and push you. Is that the case? No. Then what is that external force acting on ourselves when we are walking? I would appreciate if you can interfere with the class. Yes, friction. Now if you want to make an object at rest, to make it move, we have to apply a force. Likewise, now let's say I'm standing in one place, and if I want to move, I should experience external force according to Newton's first law. That external force is actually friction. So how it is acting, now if I'm walking, how it is acting on myself is, I keep my foot on the ground and I push it back. I push the ground backwards. Okay, so I can show you here. Okay, so what I do is I keep the leg down and I push the leg back. Okay, push the ground backwards. So I apply a friction force on the ground. Okay, I apply a friction force on the ground by pushing it backwards. Okay. So this is the friction force acting on the ground, acting on the ground by the foot. So then, according to Newton's third law, equal and opposite reaction force will be acting on the foot by the ground. So this is the friction force acting on the foot by the ground. So then this force will be an external force, unbalanced force acting on our leg, on ourselves, so that therefore we can move forward. Okay. Okay. So you can quickly draw this. Before that, I'll give you a topic. So applications of friction. Applications of friction is the topic. And then under that, the first application is uh, action of friction when walking. Okay, so you can quickly draw this. Okay, so when walking, we keep the foot on the ground and push the ground backwards, right? We push the ground backwards, so we are applying a force on the ground. So that is the friction force. Then the equal and opposite reaction force will be acting on the leg by the ground. So that becomes a external force, unbalanced force acting on us in the horizontal direction. So which make us move forward. Okay. Okay, so we'll draw another figure to illustrate this. Mhm. So here what we do, we keep the leg on the ground and we push the ground backwards. Then equal and opposite friction acts on our leg by the ground. We can write down that same friction on man from the ground on ground, and this is friction on ground by man. And weight, no reaction force. Okay. Okay, so now let's write down. When walking, the man keeps the leg on the ground and pushes the ground backwards and pushes the ground backwards and pushes the ground backwards. When walking, the man keeps his legs on the ground and pushes the ground backwards, applies a force in backward direction. Apply a force within brackets friction force in backward direction. Apply a force within brackets friction force in backward direction. First stop. And then according to Newton's third law, there will be equal and opposite reaction force acts on man by the ground. Acts on man by the ground. This force, this friction force acting on the man becomes an unbalanced force in the horizontal direction, thus the man will move forward. So that the man can walk in this direction. And by the way, here I want to emphasize that fact. Now, whenever we apply the force, let's say if we are applying force in this direction to make this object move in this direction, so the friction will be in this direction, right? So the object is moving in this direction, some speed, let's say, but friction is in this direction. But here in this case, the object or the man is also moving this direction, the friction on the man also in the same direction. So moving this direction, friction on man also in the same direction. So it is not true that the friction is always opposite to the direction of motion. Okay. So therefore it is not true that friction is always opposite to the direction of motion. Okay. So you may have get question in MCQs like true or false statements. So you may get a statement as friction is always in opposite direction to the motion of an object. So that statement is wrong. Now we will see our next example when a vehicle is moving. So friction, how friction acts there, we will see that. Right? Okay. So any questions regarding this? I hope everything's clear. So by the way, put a note on that. Otherwise, you may forget. So put a note. According to this, according to this, it is clear. It is clear for us that the friction is not always opposite to the direction of motion of the object. So according to this, it's very clear to us that the friction is not always opposite to the direction of motion of the object. So according to this, it's very clear to us that the friction is not always opposite to the direction of motion of the object. Okay, so we'll move on to the next application. Second one. Friction acting on a moving vehicle. So under that, I can take A part. A. Under that A part, engine is powered. Engine is powered two back wheels. For a second, right? Uh, when the back wheels are powered by the engine. We know if you take a vehicle, for example, car, van, or bus, there are four wheels, right? Out of these four wheels, the engine gives power to uh, back wheels, right? Normally, if you take a vehicle, it can be a van or car, the engine is powers the back wheels, right? So here we'll see how the friction acts on it. Okay, so let's say this is the front of the car. Car is moving this direction by powering the two back wheels. So it's a side view. We can see only the wheels in one side of the car. Okay, so then the engine powers the back wheel, right? Engine gives powers the back wheel. So we know in the engine the combustion air will be there. It will rotate the piston so that the motor will rotate, and then it will rotate this wheel. So this is a rough ground. We know the surface has to be rough in order to drive. Okay, if the surface is very smooth, the vehicles can't go, right? It won't work. Okay, so therefore the floor has to be rough. Okay, okay. And for example, the tires are made in a special design so that they maximize the friction. They have these patches, and then this so those cut works in the tires they have used to maximize the friction. Okay, okay, anyway, so here the engine rotates this wheel in this direction. It rotates the back wheel in this direction. So what happens from this contact point of the wheel, it pushes the ground backward. Okay, it pushes the ground backward. Okay, so that equal and opposite friction force acts on the wheel, so which becomes an unbalanced force to this car. So it makes this car move forward. Okay, similar to what we discussed in the previous one. We keep the leg round and we push the leg backwards so that equal and opposite friction force acts on the leg of the man. So it becomes the unbalanced force required to move forward so that man can walk forward. So likewise, the engine gives power to the back wheels. So the back wheels rotate in this direction. So from this contact point, it pushes the earth ground backwards. So you can see now if I rotate this direction, yeah, if I rotate this direction, it pushes this direction, right? But if I rotate in the other direction, it pushes in this direction. Okay. So here, since it's rotating this direction, at the contact, it pushes the earth in the backward direction. So then what happens? Equal and opposite force will be there. I'll mark that as F1. So this F1 is the friction force acting on the ground by the wheels. Therefore, according to Newton's third law, equal and opposite reaction force acts on the wheel of the car. So this becomes unbalanced force acting on the car in the horizontal direction so that the car will move forward. So when it start to move forward, now imagine the car is only power gives energy rotates only the back wheels, not the front wheels, right? So therefore, once now start rotating, this friction force will be there. It will be an unbalanced force in the horizontal direction. So what happens? It pushes the entire, because of that the car will move forward. So it's like this. For example, this if fiction I can think of like applying a force in this direction by F1. Like for example, if you have a object of mass placed on a surface, if you apply a force, okay, so then what happens? There will be a equal and opposite reaction force, right? So similar to that, due to this friction now, what happens? This car will tends to move forward. Therefore, there will be equal and opposite reaction force will be there in this contact point too. Okay. So again, I'll explain this part. So this is similar to what we discussed in the previous part in this kind of thing. So because of this external force acting on this car, it make this move forward so that here there's tendency to move forward. So here what happens, this point of the wheel pushes the earth this direction. Contact point pushes the earth in this direction so that again equal and opposite force will be there. So this is F2, and so now due to this F2, what happens? Due to this friction force, this becomes a moment force, moment of force. So this is a pivot point. So this rotate in again this direction. Okay. So therefore, we can see the net unbalanced force in this direction. F net is equals to F1 minus F2. So there is a net unbalanced force in the horizontal direction. Therefore, the car will accelerate or move in the forward direction. Okay. Any questions regarding this? Hope everything is clear. Okay. Please write this down. So here these two forces are acting on the ground. Okay. Okay. So quickly draw this. Don't just copy it, try to understand. Friction force is like a wife. නැතුවත් බෑ තිබුණත් කරදරයි. So now, for example, if you consider this, if you want to make this car move, the friction force must be there. If the friction force is not there, the car won't be moved. But again, the friction force becomes a resistive force. So you can see here F minus F2, right? So you can නැතුවත් බෑ අතුවත් බෑ. Okay, raise your hand once you finish writing this down or drawing this down. And by the way, guys, tomorrow we're having a session tomorrow morning, 9 a.m. to 1:30 p.m. How many of you are able to join? I need a response from each and everyone as a text message to the chat box. Please drop a message if you are joining. Yes, I can drop a message, say I can. So that session will be held from tomorrow physically in Dehiwala. Also, we will be doing the live streaming. This session I'm doing mainly because of Hero, so I prefer you should come as physical class. Atika, will you be able to join tomorrow morning? 9 to 1:30? And Zufar, how about you? Time 9 a.m. to 1:30 p.m. Maybe I'll finish around 1:15 because I have another seminar in Kolanava at 4 p.m. Atika, Zufar? Yeah, you can join through online as well. I will be doing the live streaming. If you find difficulty in transport. I'm sorry, Hirosh, if you feel like I'm doing an unfair thing to you. Uh, I'm doing this session because of you only, but if you are not there, it makes me like discouraged. So I wish you should be there, okay? So please don't think that way, okay? Okay, thank you. Okay. By the way, are you guys finished drawing this? If not, you can take a screenshot. Okay, so in our real world scenario, there are two types of uh, engine. Okay, one is uh, powering the back wheels. Normally, now if you take almost more than 70 percentage of vehicles are back wheel, and only few, I mean more than 80 percentage I can say, but only the back wheels. And there are some vehicles which are four wheel drive. So you may have seen in mostly like Jeeps and Pajeros, they will put this 4WD. This means four wheel drive. That means engine powers all four wheels. So here under this second application, we will be discussing part A, part B, and C. Okay. So we will be discussing three cases. So first case, when the back wheels are powered by the engine. So that is this case. Okay. So in real, we have two types, back wheel powered by the engine or all four wheels powered by the engine. But the front wheels powered by engine is not there, because if you are moving very fast and if you hit the brake, there will be movement movement of force due to the sudden brake, so that maybe bicycle padapu kawra itiyanam they understand it. When they go fast and hit the front brake, what happens, the bike will topple, no, right? How many of you experience that bicycle padla tinay kawda? Raise your hand. Okay. Okay, so if you have experience in riding bicycle, okay, almost everyone have experience riding bicycle. What about Atika? Have you? I didn't see you are raising your hand. I see. Okay. So those who have experience with riding bicycle, they know if they ride very fast and hit the front wheel, the back wheel will be raised, right? ඒකත් හයියෙන් ගෙවුවනම් ඉස්සරහට පෙරලෙන්න පුළුවන්. So therefore, or no any wheels are powered the front wheel. But anyway, for our study purpose, to understand how you have understood this friction force, we will do the case B as the front wheels are powered by the engine. Okay, so the part B, when the front wheels are powered by the engine, and you have to think accordingly and draw the figure and mark the friction forces. Okay, so let's move on to the next part. So when the front wheels, so you have to do this part B, when the front wheels are powered by the engine. Now these type of vehicles are not there in the real world, but you can draw the friction. I just want you to see whether you have understood this part. Okay, I'll give you 4 minutes. Draw the vehicle and then mark all the forces. Okay, the engine powers the front wheel. Okay, you have to mark all the forces. Not all the forces, like no need to mark the weight and normal reaction force. It's only the mark the all friction forces acting in the system. And I would need each of you to send your workings. You have to capture it and send it to me. Make it soon. Can you send me the workings? So when we have two equal and opposite friction force, how is the result? Okay, in the previous one, so we have like this, right? So, okay, so this rotates the back wheel. So there will be a force acting on the ground, F1. So equal and opposite friction force acting on the wheel, F1. And due to this, now this uh, slides. So therefore, this pushes the earth this direction, F2, and therefore equal and opposite reaction forces acts on the wheel F2, and therefore this wheel also rotate in this same direction. So here if you consider this, F1 is in this direction and F2 is in this direction. And here obviously F1 is greater than F2, otherwise the car won't move in this direction. Okay, so here F1, now if you consider these two, they are equal and opposite, but this is acting on the wheel and this is acting on the ground. Similarly, here F2, this is acting on the ground, this is acting on the wheel. So in the horizontal direction only two forces, only these two forces are there. So F1 is greater than F2, so resultant will be in this direction, F1 minus F2. So this is the resultant force. Hirosh, did I answer to your question? Okay. And please mark the force and send me quickly. They're all in same plane, but two of the forces acting on the ground and then two of the force acting on the wheels. Right? Yeah. Okay, please send me your workings. I want to see. It's okay to be wrong because we are learning. This is not an exam. We are not going to grade anyone. We know all of you are very talented. Okay. So it's okay to be wrong. Just once you're done, please send to me. So I just want to see. I want to understand your. Okay. Hirosh, are you there? Abhishani, I finished. Okay, that's fine. And Atika, Zufar, okay. Let me check. Thank you, Hirosh. I appreciate sending your workings here. So this wheel rotates this direction, so pushes the earth backwards. Now here one thing that is wrong is you can see here this gap between the ground and the force. Should not mark like that. You have to mark this force exactly from the contact point because friction acts from there. So this when this engine powers this wheel, it rotates this direction so that it pushes the earth this direction. Okay, so that is, let's say, mark F1 here. Okay, F1, and then equal and opposite reaction force acts on the wheel from the ground in the opposite direction, which is in the forward direction. So okay, so here this will be F1 and this F1. And now this is a unbalanced force, external force to this car. So this car now starts to move this direction. So when it starts to move, this point of the car pushes the earth in this direction, forward direction. So yeah, F2. So then equal and opposite reaction force will act on the wheel from the ground in this direction, F2, and so this makes a moment about this point. So we know here the force times perpendicular distance will the moment, therefore this will rotate in this direction. Okay. So therefore the car will move in this direction. So therefore the net force F net will be in this direction. So here F1 acting on the wheel minus F2. Okay. So I mark again that this pushes the ground in this direction. So therefore equal and opposite force acts on the wheel from the ground in this direction. So this force will mark F1, F1. Now due to this, this wheel start to slip or skid on the ground. So therefore this point of the wheel pushes the ground in this direction. So therefore equal and opposite reaction force acts on the wheel. So let's mark this as F2. So therefore, due to this F2 force acting on the wheel, this force is acting on the ground. So it does nothing on the car. Okay. But this one is acting on the wheel. So if you consider from this pivot point, there will be a, if you know this radius of the wheel, so there will be a torque. You have studied moment of force times perpendicular distance, which makes this rotate. We will start very soon the moment of force. Okay. So therefore, the net force F net in the forward direction, which is equals to F1 minus F2. Okay. So then the third one, I hope all of you do the same thing. If not, you can correct it. Okay. And the third case, when the four wheels are powered by the engine. C. When the four wheels are powered by the engine, all four wheels. All four. All four wheels are powered by the engine. Okay, so you have to draw this. Give it a try. I'll give you only 3 minutes now. By the way, can anyone tell me what is the advantage of using four-wheel drive? Anyone of you know the advantage of using four-wheel drive? More speed. Now, if the engine provide, if the combustion brings same energy, so it doesn't. If you use four wheels, means it does not increase the speed because the speed depends on how much of energy output from the engine. So it is a engine property. The speed is, or else what you can do is to increase the speed. If the engine gives same output, you can make the vehicle less heavier. එන්ජින් එක එකම අවුට්පුට් එකක් දෙනවා නම් 4 wheels කරා කියලා ස්පීඩ් එක වැඩි වෙන්නේ. What do you mean by stabilized? Guys, you can unmute and talk anytime. That's totally okay. And in fact, I like when you are interfere. I mean, while as rather than the texting chat message, if you talk, it will be very interactive. Okay. Actually, one main exam advantage is, for example, let's take driving in a mud area. If the two wheels, let's say the vehicle is powered by two wheels, so if the both wheels are in the mud, so it is difficult to get out from the mud. But if a four-wheel drive, if the back two wheels are in the mud, still the front wheels can make a force and come out from the mud. So most of the time, these four-wheel drive are like used for this Pajeros, Jeep, Safari vehicles. They only use this four-wheel, which like for example, vehicles that are used in adventures. Did you understand? Why front wheel powered is not success? Zufar, were you not there in the class when I was explaining about the bicycle? Now, if you have a ride bicycle, you know when you come with high speed and if you hit the brake, what happens? The bike will, uh, the back wheel will be lifted, right? Or if you have enough speed, you may topple and fall, right? So that the same thing would happen for other vehicles also. Like when come with large speed and if you hit the brake, the vehicle can topple. So therefore, no any vehicles are front wheel. So almost more than 80 everything back wheel drive, but only these specified vehicles have four wheel drives. Okay, did you all mark this? Please send me your workings, please. Make me happy. I need each and everyone send your workings. Please. Abhishani, can you send your working? I mean, just only have to mark the forces of the friction settings on wheels. Atika, Hirosh, Sufar, can you send the working, please? It's very important for me to see your workings. Then only I can get an idea whether you have understood or not. So without knowing that fact, without knowing that whether you have understood or not, as a teacher, I can't move forward, right? So please think about myself, okay? And please try to send your work. It's okay to be wrong. It's totally fine to be wrong. But the thing is, I want to know which level you understand these theorems, okay? Okay. Mm, no. No. But I appreciate you both for sending your workings, means a lot. So now I get some idea, like how extent you understand the lesson. Okay, so here I'll explain. So here the engine powers the both wheels, right? The engine powers the both, I mean all four wheels. Okay, so the engine rotates this wheel. So therefore this wheel pushes the earth backwards. So equal and opposite force will be there acting on here. F1, F1. Okay, so again the engine rotates this wheel. So this wheel pushes the earth backwards. So equal and opposite force acts on the wheel. F2, F2, let's move. So the now in this time both the forces. So here the force on the wheel is also forward in forward direction. Here the force in the wheel also forward direction. Therefore F net is equals to F1 plus F2. because the both wheels pushes the ground backwards, right? So therefore, in this case, F1 plus F2. That's why even if the back wheels are in the mud, the front wheel can make the so if it's in mud, can't produce an external force in the forward direction, but this one can produce. Or maybe if the front wheels are in the mud, the back wheels can make a push and move forward. Okay, so that's the biggest advantage in four-wheel drive. Okay, so please correct it. Both can be F1, yeah. Both can be equal to F1. For that, there has to be the same tires, and also the mass distribution has to be symmetric both sides. So for example, if the engine is here, the engine is here more, maybe mostly in the back, engine will be up. Let's say if the mass distribution is different, then the frictions will be different. You can mark it as F1, F2, because we know the car is not symmetric, right? So we can't say they have the same forces, because the F is proportional to R, normal reaction force. So, and then normal reaction force, by considering the vertical equilibrium, R is equals to the weight in G. So if this part is heavier, this part is much heavier, I mean this side is much heavier than this side, then this side normal reaction force is larger than this side normal reaction force. Therefore, then this side will be, friction will be high. Okay. Okay. So let's do some questions based on friction. Give you some questions. Okay. 10 kilogram object is placed on a rough horizontal surface. The static friction coefficient between the object and the ground is 0.7. What is the unit of friction coefficient? What is the unit of static friction coefficient? Guys, okay. So it has no units. Okay. The static friction coefficient between the object and the ground is 0.7. Okay. Determine whether the object will move or not in the following determine whether the object will move or not in the following circumstances. If the object moves, then find its acceleration. Okay, first one. Consider applying force of 10 Newton. Okay, you can start with the first question. Okay, I'm finished with the first question. Raise your hand. Abhishan, you finished? Okay, so the first one I will help you. So first we want to find whether the object will accelerate or not. Okay, so it's placed on a rough surface, right? Therefore, you have to find the first you have to find the maximum static friction, right? So remark all the forces acting on this. So its weight vertically downward from its center of gravity, and then normal reaction force will be there, and friction will be in the opposite direction. So here R mg, we can mark 10 kilograms or 100 Newton. So considering the vertical equilibrium, okay, so let's write like that. Considering the vertical equilibrium. So considering the vertical equilibrium, R minus 100 equals 0. Or if you want, you can apply Newton's second law also, right, in vertical direction. So here this, okay, I will write in both methods. So vertical direction. So what are the force acting in vertical direction? Vertically upward R will be there. So 100 Newton is downward opposite to the direction I have considered. So mass is 10 and it's not accelerating in vertical direction, so it's 0. So therefore again R equals to 100 Newton. Okay. So then R is 100 Newton. Then after that I can find Fs, static friction coefficient, that is maximum limiting static friction force, the maximum friction force can have. So that is equals to nu into nu s into R. So Fs is equals to 0.7 into 100. Therefore Fs equals to uh, Fs equals to 100 into 0.7, 70 Newton, isn't it? Yeah. Hold on. 10 kilogram. So mg 100 Newton. Okay. So therefore Fs is equals to 0.7 into 100, 70 Newton. So therefore the maximum force is 70 Newton. Therefore here we applied 10 Newton. Therefore the friction also will be equal and opposite 10 Newton. Did you understand? Mm, normally, yeah. Okay. Did you understand? Okay. What about Abhi and Atika, Zufar? Yeah, here first we want to find the maximum friction force. Okay. So we studied, right, the friction force has a maximum value, that is Fs. So if you apply a force less than 70 Newton, the object won't move, right? If I want to make it move, I have to apply a force at least little greater than 70 Newton. Okay. So until that, the object will remains stationary. The friction force will be equal and opposite to the applied force. Okay. Okay, so similarly you can do the second one and third one. Now again, yes, in the second one, no need to find the fs. Once you found the fs, that's enough. It's the maximum value. Okay, so then for the second question, so again, uh, r will be equal to 100, right? So you can find the applied force is 14 Newton. Therefore, now if you want to make this move, you have to apply a force that is greater than 70 Newton, because the maximum friction force is 70 Newton. Okay, so here also therefore the friction is, so here you had to state whether the object will move or not. So therefore here object will not move. Object will not move. Also, I should have mentioned, also find the magnitude of the friction force. Yeah, I think it's better, or else, yeah, it should be better. Also find the magnitude of the friction force. Magnitude of friction force acting on the object. Okay, so here the friction force Fp equals to 10 Newton. So here also we can say object will not move. Object will not want to move. So friction force is equals to, you can say equals F equals 14 Newton. So in the third one also, object will not move. Because we can see the resultant force in this direction, 20 Newton. So therefore, still it's very less than the limiting friction force. So object will not move. F equals 20 Newton. Okay, any questions? Okay, so no questions. I hope everyone understood very well. Kiela. So I will give you the question number 4, 5, 6, 7, blah, blah. Number 4. Okay, do the fourth question. The first thing is you have to identify whether the object will move or not, and then the magnitude of the friction force on the object. Okay, I got the answer from Abhishani. It's correct. Okay. Okay. We have calculated that the static friction is uh, limiting static friction Fs is 70 Newton. So here now we can find the resultant force. The resultant force will be in this direction 80 newtons. So 80 Newton is greater than Fs. Therefore, object will move. Okay. So the object will move, and then to find the acceleration, we can use uh, F equals ma. But first, yeah. So we can use F equals ma in this direction. So F equals to, in this direction, 120 minus the friction force is now the maximum. It will be in the opposite direction, 70 Newton. And the mass is 10 kilogram, 10 into A. So here please remember we are finding only the initial, the moment of when the object starts to slide. Because when it starts to slide, after very second, very moment, after a very short time, what happens? This friction force will change. Therefore, acceleration will change. I'll explain you. First, I will find the value. I will get a value for the acceleration. 120 minus 70 is 50 over 10 equals 5 meters per second square. So after this, the very initial, when it start to accelerate, at that moment the acceleration is. After that, what happens? The friction force will be equals to uh, Fk, the kinetic friction. Okay, so after that, what we have to, if you want to find the acceleration of this, the very initial acceleration. For that instant only, this acceleration is true. After that, if you want to find the acceleration, you have to again write the F equals ma in this direction. So force in this direction is 80 Newton minus, sorry, here we have to take 80 here, right? Because the resultant is 80 Newtons. Okay, so therefore, 80 minus 10, 10 divided by 10 equals 1 meters per second square. Okay, so here 80 minus, here then we had to put Fk, kinetic friction, and mass is 10 into A dash, let's say. So therefore A dash is equals to 80 minus Fk. Now we can't find Fk because we don't know the value of new K, right? So A dash equals to 80 minus Fk over 10. Okay. So here I am, and just wanted to explain you this. This is the instantaneous. When it start to slide, at that very instant, acceleration is this initial acceleration. But after very second, like it can be 0.00000001 seconds. After very that time also, then the force will be changed to kinetic friction. For the friction force will change to kinetic friction because it starts sliding, right? So therefore, in that case, the acceleration we have to compute from this expression. If you know the nu k value, you can find Fk equals to nu k times R equals to 100 newtons. Okay, did you all understand? Please raise your hand. Hey, Raj, okay, two hand raises. Only two. Three, okay. Your hand is raised. Good. So if they ask the initial acceleration, you should find this. Okay. Or else after the acceleration, this is what you have to find. Okay. One more example. Okay, another two more examples. I think. Let's make it 60 Newton. 20 Newton and 20 Newton. Okay. State whether the object will move or not, and then yeah. Okay, here you have 20 newtons, 70 newton, 30 newton. So in question number 5 and 6, state only whether the object will move or not. Okay. Okay, I got the correct answers from Hirosh. The answer is correct for both question number 5 and 6. Good. Okay, Abhishani, good. You can do the sixth question also. Okay, in question number 5, we can see the resultant is here 20 and 70, 90, 90 minus 30. So there is a resultant of 60 Newton. So here we can say the resultant for 60 Newton is smaller than the Fs. Therefore, F equals to 60 Newton. The friction force is equal to 60 Newton. Will not move. Okay, now here in this one, apparently you will think this will move because the applied force is in the horizontal direction less than 70 Newton. But actually here, since we have applied a force in downward direction, the maximum Fs will increase. Okay, because Fs is the normal reaction force. So here first you have to find the normal reaction force. So let's mark the forces. So weight vertically downward in 100 Newton, and normal reaction force vertically upward R. So I can apply, we can consider the vertical equilibrium, or we can use, we can consider the Newton's second law. We can apply Newton's second law in this direction. F equals ma. So the net force R minus 100 minus 100. So 100, 200 are in downward direction. I'm using the equation upward direction equals to mass 10 times acceleration is 0. It's not moving in vertical direction. So therefore here R equals to 200 Newton. Then we can find Fs, that is equals to nu s times R. Therefore Fs is equal to 0.7 into 200 Newton. Therefore Fs equals, so 7 into 20, 140 Newton. So therefore now the maximum friction force has increased to 140 Newton. So then the object will not move. Object will not move, and F equals to, that friction force is equals to 15 Newton. Okay. Did you all understand? Atika, did you understand? Okay, good. Let's do one last question. 70 root 2 newtons. Question number 7. So the force is acting on this object, making angle 45 degrees to the horizontal. Okay. So first state whether the object will move or not. Okay, I got an answer from Atika, but I think the answer may change. Let's see. Okay, so here first, by the way, I think for Atika we didn't done vector resolving in all. So I just explain. You try to understand. If you didn't understand, don't worry about it. So I got same answer from Hirosh and Abhishani. They said it won't move. Okay, so let's see this what will happen. So first I can resolve resolve this vector into two perpendicular directions. So one is in this direction, it will be 70 root 2 cos 45, and this one 70 root 2 sine 45. Okay, so therefore first I can find the normal reaction force in vertical direction. Okay, so first let's the other forces weight downward mg, and the normal reaction force will be there vertically upward r. So I can find the r by considering the vertical equilibrium. So in upward we have r plus 70 root 2 sine 45 minus mg, which is 100 Newton. So 100 equal to 0, therefore r equals 100 minus 70 root 2 into sine 45 is 1 over root 2. So root 2 cancel. So R equals 30 Newton. Then we can find Fs, which is mu s times R. So therefore, since now there is a vertical force, it's because of this force, the R value will be decreased. So you can see it's 30 Newton. Therefore, the maximum force also, friction also will be decreases. So then 0.7 into 30 Newton, which is 21 Newton. So in the horizontal direction, we have force of 70 root 2 cos 45, that is equals to 70 root 2 into 1 over root 2. So therefore we get 70 Newton. So this is greater than the Fs. So 70 Newton is greater than Fs. Therefore object will move. I think both of you didn't consider this component. Okay, so because now if there's a table, if you give some support, the push between the thrust between the contact will be decreases, or the normal reaction force will decreases. Okay, because of this, it will give a support. Right? Okay. So therefore, the maximum static friction will change. So therefore, it will move. Okay. So with this conclude the session in class because tomorrow morning to have another class, right? By the way, all theory from this part, forces and motion finish, should I start doing classified? You can start past paper questions. Yeah, and actually we have more in mechanics. We had to discuss. I mean, in Newton's laws of motion, we had to discuss in the Dunutara, the string balance, the readings in string balance, and then inclined plane, what are the forces in inclined plane, acceleration, and those things, and then pulley systems. Three more things we had to do. We will be, most of the things we will cover within this week, we can finish all the sections, most probably. And also, I'm planning to start a mechanics paper class on Mondays 9 to 11. We will discuss further about it in the tomorrow session, end of tomorrow session, because now only few people are there. So anyway, okay. If you have any questions regarding today's class, you can ask. And please make sure to attend tomorrow's class. I think all of you can join. Atka can, Navish can, Hirosh will come. And Zufar, I think you also can join through online. Yeah, tomorrow morning, 9 a.m. to 1:30 p.m. Okay. Okay, then have a good sleep, good night, sweet dreams. Take care. Hope you will do mechanics questions in your dream. Good night.